Alright, so today we'll be talking about volumes of prisms and cylinders. Okay, now composite space figures. Uh, we're going to actually talk about Cavalari's principle. Cavalari's principle is that if you take a shape, and whether you make it oblique or a right shape or however you want to draw the shape, that as long as the consistency with the cross sections are there. So in other words, if I were to do a cross section, for example, let's do it right in the middle. Okay, cross section from here to here. Okay. And as I continue to do cross sections up and down this shape, as long as they stay consistent, and let's say I tilted this entire thing over, okay, and made, an oblique pyramid like this, as long as these stayed the same, okay, as the one of a right figure, in other words, was perpendicular with the ground, okay, I would have the same area as that shape, okay? I'm sorry, not area, volume as that shape. So that's where we're going to talk about volume of a prism. Now, it doesn't matter about it whether it's oblique or not. What you do is you take the area of the base and you times it by the height of the actual object. Okay, so technically all you need to know is, length, width, and height. And obviously that's of a cube, but you can also do it for a rectangular prism. Okay, so once again, area of the base could be length times width. It could be a triangle, which would be 1/2 times base times height. It could be a regular shape, which is 1/2 times apothem times perimeter of that shape. Whatever you're dealing with, the area of the base formula could be different. But the height is pretty much going to be the same, whether it be altitude or whether it be the actual height of a right figure. Now, the volume of a cylinder is actually going to be pi times radius squared, which is, as you guys probably recognize, the formula for the area of a square, or not square, a circle, and times the height. So what you're going to be doing is just multiplying the height by that. Now, the ideas behind this actually come from Cavalari's principle, in that if you take these subsections, they're always going to be consistent right there. But also at the same time, if you notice, if I keep doing this and finding the height of these infinitesimally really small or these really small rectangles that I'm stacking on top of each other to make up this entirety of the shape, I can actually find the volume, because all I need to do is just take the area of one of them and times it by how many times the height is going to be there. So if I know the height of each one of these pieces of papers, and I can tell you how many go into there, I can actually work with this. Volume formulas are very different from the surface area formulas, in that the volume formulas are actually arrived to via calculus. So this is actually the results of calculus. Okay, so a lot of these formulas you're going to see are results of complicated calculus formulas for volume. It's really kind of cool stuff that you can actually work with. Okay, I believe it is, I want to say calculus 3 is where you actually learn how to actually do this stuff. Okay, but for right now, just enjoy the spoils of their labor, the fruits of their labor, just so that you can be able to plug in the numbers and be able to figure it out. Okay, now a composite space figure. Okay, a composite space figure is going to be a figure made up of several different type of space figures. Okay, so if you actually have to find the area of like something that looks like this, okay, I just realized in drawing this that this is not the best semicircle that I could have drawn. Okay, but anyways, let's say you were dealing with a figure that looked like this, and let's say that you didn't know. Sorry, I need to get, oh jeez, undo. There we go. Let's move that. Let's get rid of this. Yeah, let's get rid of that. There we go. Alright, and let's move these bad boys back. Okay. Let's say that it kind of looked like you were actually dealing with a figure. I kind of gave away a hint as to what we're going to be doing, but if you're dealing with a shape like this that looks like it's a composite of several or just a couple of figures that you actually know, go ahead and draw those figures out and be able to work with it, you know. All right, so when I draw out the figure, it's going to be a lot easier because you're going to be dealing with a rectangular prism, so the volume of this is going to be the area of the base or times the height. Okay, then I'm going to add that with this other part. Let's just say for argument's sake that this is actually half of a cylinder. So you'd be doing half of pi radius squared times height. Okay? And obviously the height would be the same for both objects, just the only two different things would be the radius and the actual area of this base. Well, actually you could use the radius or the base. You could actually say about halfway of the base would be the radius. So you could actually use that there. Okay? But in looking at this, you could actually make a composite space figure by using shapes you do know. Okay? And just working with it. All right, and that's it for dealing with volumes of prisms and cylinders and Cavalari's principle and composite space figures. We'll talk to you later. Bye.